Hi guys, welcome back. So this is a continuation video of chapter 4, Introduction to Buffer Overflows Fuzzing. So if you guys missed my previous videos, chapter 1 got 4 videos and chapter 2 got 3 videos, chapter 3 got 2 videos and chapter 4 got 1 videos. And this is the second video of chapter 4. So let's go to the topic now. What is fuzzing? Fuzzing is a way of discovering bugs in software by providing randomized input to programs to find test cases that cause a crash. Fuzzing your program can give you a quick view on their overall robustness and help you find and fix critical bugs. It is ultimately a black box technique requiring no access to source code, but it can still be used against software of which you do have source code. This is because it will potentially find bugs more quickly and avoid the need to review lots of code. Once a crash is detected, if you have the source code, it should become much easier to fix. Okay. Fuzzing workflow. This process is composed of several steps that can be enumerated as you guys can see in the picture. Initially, the target system must be identified to select the specific fuzzer, the target input, and the right character set inputs in order to generate the final payload to test. After the target input identifications, the payload list is generated. Several types of data can be included, such as strings, digits, characters, and combinations between them within different input size. Next, the payload are executed by starting the fuzzer in the right conditions. A crucial part of this process is monitoring the system behavior and log defects. Here is where we analyze through offline format the result of the test. The potential flaw, bug or crash is detected in this phase. Finally, the specially crafted payload can be created according to the result obtained from the fuzzing process to take advantage of the target system, resulting in the creation of the final exploits. So this is how it works, the fuzzing workflow, when it comes fuzzing workflow. Okay, the step by step. Test environment and tools used. So what I'm going to use is Kali Linux virtual machine as an attacker machines. So the tools we are going to use Metasploit framework, Python's the latest versions, and Python scripts to pass fuzzy inputs to vulnservers.exe, and editors such as Nano, Vim to modify the Python scripts. Okay, so and then Windows 10 machines, virtual machine as a victim machines. So you guys can download this vuln server, and then the debugger. The debugger we are going to use x64, x32, but you can get it from x64 website directly. Okay, so let's go to the machine now, test machine. Okay, so I have already installed that x32 debugger. Okay, so and then the vuln server I have already downloaded. Okay, so so vuln server is a Windows based TCP server application that is designed to be exploited. So the program is intended to be used as a learning tool to teach about the process of software exploitations, as well as a good victim program for testing new exploitation technique and shell code. Okay, so this is purely for testing purpose. So you guys can download it from the link which I provided in the presentations and the previous slide. Okay, so now just open this command prompt. So let me show you how to do that. So just run as administrator, and then just copy the link, and then sorry, it's closed. Okay. So now copy the location here. Okay, so now So if you guys want to specify the port, so you guys can do it. So what I'm doing is a 5555. So or else you can just leave it is by default it's 9999. So this is a default port for this exe. Okay, so one server exe. So I'm specifying this port number 5555. So just enter. So if you guys want to check the port, so you can also check netstat -anob, sorry, and then find 5555, enter. So it's listening. So as you guys can see here, so let's say control shift. So let me test again now. You see it's not listening. Okay, so with these commands on netstat, so you can check whether the server is listening on the specific port number or not by executing the netstat. Okay, so now we can open the X debugger x32, because that Windows one server is a 32-bit supported file. So that's why we are opening this, and then you can just click attach the file menu, attach. Sorry, I need to open run as administrator. So okay, run as administrator, and then file menu, attach. So now I'm going to run the file again. Okay, enter. So now just refresh. So now you guys can see here one server. Just double click. Okay, so this is a stack, you know, so as we guys discussed this previous video, but with a immunity debugger. So just for change, because so x64 is one of my favorite tools, so that's why I'm using this for you know, for this fuzzing. So first you guys can see here, just take a look that EIP and then EBP and then ESP flag values. So just take a look, the closer look. So when we run these programs, it will change. Okay, so let's connect the Kali Linux machine now. So clear. So now let's create that Python script. So let's open the fuzz. Okay, so first let's put the library here. So import socket and OS system times everything. So and then this is a Windows machine IP address, so 192.168.0.128, and then port number. So what we are going to use it, what we are testing here. Okay, and then buffer, it will be bunch of A letter, so you guys can see here. And then, you know, I will increase this every time 200. Okay, so here you guys can see. And then buffer, which will be bunch of A, and you know, I will increase it 200s every time, and then append with the buffer. And then for each string in the buffer, I will print a fuzzing turn, which is the function contain the buffer overflow vulnerabilities with numbers, so whatever the number is. And then I created a socket and then connect to the host and port, and then I send the tron, and then I send a tron, and then I close this. So at the end, so at this end, so added the time.sleep, so this will help to see you know, the changing of memory, so when we execute, you know. So now Okay, now let's close it. Quite so. Okay, let's run this. So let's run this. Script. So this started now. Let's go back to the Windows machine. So, okay, so now you guys can see this. So the programs crashes. So as you guys can see here, the 414141, I know at the bottom of the stack, and the top of the stack, so you can see the bunch of A's in the hex dump in the X debugger. Okay, so you guys can also see here in the stack here. You need to close it if you want to test again. So you need to close it and then run as a administrator. So this is because the program crashes, so you need to run it every time, you know. So and then attach, then go back, so then test, right? So now try refresh. So then you guys can see here. So now if you guys want to test again, so like this, you know. So now we can see controlling EBP, ESP, EIP. So the learning objective of this session to understand concepts behind buffer overflow attack and fuzzing using Python scripts to apply techniques to buffer overflow attack for controlling EBP, ESP and EIP. So let me open the Windows machine here. So as you guys can see that A. So we have managed to find out that EIP, the bottom of stack, you know, the vulnerabilities. So and then top of the stacks, you know. So we can just right click and follow in dumps. So you guys can see here's a bunch of A's, you know. So now the tricky point is how to find the exact location of EIP. So it could be a couple of space before the ESP. It could be in the bottom of the stack and top of the stack. It could be in the middle of the stack, you know. So that's a problem. So how actually we can locate that? So that's a really tricky part. So let's open the calling machines. So how can we find the exact location of EIP, you know? How many A's in the question? How many A's do I need to send EIP? So we have a couple of ways to do that. So the more manual one and the easiest one, so we can send the unique string, all of the characters, so we can see what is specific for string or actually written in the EIP. So almost 6,000 strings, you know, is very difficult to find. So for this we can use the Ruby script, you know. So it comes with a bundle, the Metasploit frameworks. So in the Linux mission, so we can see you know, we can create a unique string of 5900 characters using a Ruby scripts called pattern create.rb from the Metasploit framework. So let's see. So where is, so we can just copy these and then okay, and then enter 5900. So let's enter. So you guys can see here. So we can now going to copy this string from the terminal, the output string. Okay, just copy, and then so we can now open the previous script. So nano fuzzy.py. So now we are going to modify slightly. So I'm going to remove this, and then right click, paste. Okay, and then just remove this one. So I'm going to add char. Okay, and then buffer. So I'm going to remove this one. Okay, so now we can go back to that Windows machine. Okay, so just close it. You have to close this every time this is the server crash, you know, the program crashes. So this is a bit painful. Okay, so now we can run as administrator. So we can run. Okay, so we can attach this one server again. Attach it. So now go back to the Kali Linux machines. So we can now run the script. Okay, this is a modified scripts. Okay, so I guess don't get confused. So this is modified scripts. So let me show you again. So you guys can see this is now added. Okay, so let's run this script now using the Python. Oops, sorry, there is a typo here. So this is very important, guys. So you have to modify the script. So just make sure, guys, the quotation, double quotations in between the string, and then so here, so I'm going to change buffer. Okay, so that's it, guys. So I'm going to save this. Okay, so now we can now we can go back. So now we can run this server, the Vuln server, and then port number. So now we can run as administrator, the X debugger. Okay, go to file menu, attach, and then attach here. Okay, so now go back Kali machines and run the file, the modified file. So now go back the Windows machine. So you guys notice here there is no more, there is no bunch of A's, 41 41 41s. So we can now see that the specific strings, 6F 43376F, so now we know that the specific locations, and just copy that value. So wait, before we can now locate the pattern offset. So this tool is really helpful to find the bytes offset. Okay, locate offsets. We can just copy and then paste. Can now Q, enter Q. So now we have to enter this EIP. What is that? 6F4A, sorry, 6F433, 76F, 76F. Okay, so now we have copied the value here. So as you guys can see, the EIP value, the bottom of the stack. Okay, so now we can enter. So now the exact match offsets, so you guys can see here 2002. So I don't want to trust this, so now custom script. So we can just modify the script once again. So adding the hash, and then so here I'm going to add a streaks and then 202. So what we see, and then plus symbol b 4 times, and then plus symbol, and then C capital, multiplications says multiply 0, and then 2002 minus 4. Okay, so and that's it. So we can now go back to the Windows machine, close it. So run as administrator. So we can now start the server again. File menu, attach, then attach. Okay, so go back to the calling machine, run the script again. We can now go back to the Windows machine. So now you guys can see here, so now you guys can see here that EIP values is 424242, you know, the bottom of the stack, and then top of the stack ESP, you guys can see here the CC, you know, the characters. So you just right click and then follow in dump, you just scroll up a little bit, so you guys can see the combination of the character C, and then in between you guys can see here B character, right, 4B. Okay, so now we know the location of 4Bs, so we can now locate that exact location of EIPs, you know. So now we can control the execution flow of vulnerable server, that exe, you know. So now we know how to locate and how to execute the flow of vulnerable server. So this is really very useful piece of information, you know, so that the tools, everything is really useful when you guys doing the fuzzing. So you guys please remember, so these two tools are very useful. So Ruby script to create a combination of unique strings of given length. So these strings that can be used in our exploit scripts called fuzzy.py to note down the location of EIP, and then pattern offset is this Ruby script that helps in finding the length of string that we need to send to override the location of EIP. Okay, bad characters. Now we can see understand concept behind buffer overflow attack and understands characters that can stop the execution flow of a payload. Find out which set of characters can affect the execution of the payloads. Okay, so let's open that. So let's open the payload again. So now we can now get the bad characters. Scroll down. So can just copy. So let's copy this. Okay, and then so we can now so we can now just modify here plus bad chars. So remember, after this part we will filling the EBP, which is the bottom of the stack. So then we found out EIP. Okay, and then so the bad chars is the one is executable, so we are finding that ESP. Okay, so now we can now save this script. Okay, so now we have to do the same process again. Just close it, then run as administrator. Sorry, before that we have to run this 555, enter, then run as administrator, then file, attach, one server. Okay, now go back, Python, enter. So now go back the Windows servers. Okay, so now you guys can see here that EBP contained the 4141, so which is ACE. Okay, and then you guys can see here that EIP representing the 4242 the B characters, so let me show you here. So you guys can see here the 4 character. Okay, so the B's, but we can now see that dump, the ESP following dump. Okay, so now you guys can see here is a 01. So let me open the Windows machines. So you guys can see here 01, 02, 03. So and then little bit scroll down, you guys can see the bunch of A's and then B, so the EIP, so it's represented B. Okay, now we can check just removing over it the ESP value. Okay, we just removed that X01. So we can now just save this file, the script, Python script. So we can now try check, start the server, run as administrator, file, attach. Okay, so now go back on fuzzy. So we can now go back to Windows machines. So now go to the ESP, follow in dump. So you guys can see here, so 01, it's removed, and then it start from 02, 03, 04, you know. So you guys can see here the bunch of A's and then the B. So EIP, you know, is represent that B, bunch of B. Now you know that we have overwritten that address space of ESP with a bad chars. So remember that never hard code the address that EIP points to. So you need to find out the generic address that ESP point to and pass that to EIP. Okay.
So that's it guys for this video. So we have completed the chapter 4, and the next video we will see exploitation techniques. So we will see more interesting topics there, so like cross-site scripting, SQL injections, you know, the password attacks, and how to use the MSF enum tools. So we will see in next topics, next chapter. Okay,
please subscribe my channel, press the bell button to get more update, share the video to your friends guys. See you, bye bye.